First of all, I feel like a prisoner. The things connected to me, and back there somebody is taking pictures. Anyway, when Muhammad said that I will have to say also something here. So I said, what should I do? Could I just do a general presentation, thanking people and so on? He said, no. Everybody is doing academic presentations, so you have to do an academic presentation, and you don't need to thank anybody now. So you will remain thankless for a while. And then some days later, he came and he said, okay, you can talk about your philosophy of research, and also you can give us an overview of research. Philosophy part was easy because I don't have any unique philosophy. The overview part was a little more difficult. Then I thought about what should I say, because if you were in an area for 40 years or more, then there are lots of bits and pieces you do. So I started thinking about what I could do. So I was thinking through my work over the years. Then I realized, is it okay if I move up picture-wise? Okay. So the three major streams of research that I did, besides many bits and pieces here and there, one was on machine scheduling, which started with my dissertation. My dissertation had 4 essays, 2 were in machine scheduling. And then I stopped for a while, and then I got 2 co-authors. You always need to have good co-authors for research. So I got 2 co-authors in University of Dayton, and we had some papers. Actually, that's probably the area where I have the maximum number of papers. It's actually an analytical work, and I try to sell it as MIS. Nobody really believed it, and actually, I don't blame them. The other part was database management. That also started with my dissertation. My dissertation had 2 parts, machine scheduling 2 papers, and database management modeling 2 papers. Okay, and there was no connection between that. So my title of my dissertation is Essays on Database and Scheduling Systems, and CMU is an interesting place. They allowed me to submit it as a dissertation. Okay, no connection between the 2. Okay, and finally, I did some empirical work with colleagues here, and we talked about digital traces, and in particular, impact of web technologies on sales and returns. Okay. The database part, later on, we did some heterogeneous database work with Sumit, Devde, and so on. And I was thinking about maybe I should talk about them. Then doing 3 would be very difficult. Then I was thinking, so first one was analytic, second was analytic and numerical, third one was completely empirical. So I decided that maybe I should concentrate on 2. Then I was thinking, the second one was some analytical and numerical, and third one was empirical. So I decided maybe these 2 would be the right ones. There's one other reason. These 2, the topic that I will talk about, have more general interest than just IS. Okay. The second one, you may not think that way now, but later on, hopefully, you'll understand what I am saying. So those 2 I will talk about, and I will talk about specifically. Why is it not moving? This is not my clicker, so that's why I'm. So I will talk about heterogeneous databases and impact of web technologies on sales and returns. Okay. Also, there's another reason why I'm talking about these 2. The first one we started before I came to Purdue in 2002, and then I continued. And the second one I started when I was midway through my career, tenure at Purdue, and continued until recently. MSc is management science, and so on. Sumit, don't take pictures. Okay. There's one other thing you can figure out from that. If I am involved in a project, we don't get any paper in less than 3 to 5 years. Okay. So, but that has nothing to do with my co-authors. Okay. I should mention about one other thing. that since I have to cover two different topics and I have 55 pages, slides, it would be nice if you don't ask questions now, unless it's a burning question. If you ask questions toward the end, then probably I will be able to finish. Okay? So that way I'm stopping some people who ask questions that I cannot answer. Okay? Okay. So there are a couple of things I would mention. The apologies to those who have seen this work before. Some PhD students have seen both. Okay? Some people have seen the first one, more people have seen the second one. Jungpil has seen the various versions of the second paper in different universities. So my apologies to that. And I didn't want to present anything that I'm doing now. I'm working on only one research project now, and then I didn't want to present that here. So let's start with the first one. It was done with Deb Day and Sumit Sarkar. Okay? Sumit is here, Deb is not here. Let me mention what we mean by heterogeneous databases. There are lots of companies which are multinational companies. You have to get data from databases in different places. Okay? And they may not be consistently designed. The units could be different. Okay? The product unit in one place could be in pounds, one place could be kilograms. Precision could be different. One could be just dollars, one could be dollars and cents, and so on. So they could be different. So there are lots of places, particularly these days, where you need to extract data from different databases which are not uniformly designed. Okay. By the way, I should mention one other thing. When I discuss these two papers, these topics, you will realize this is fairly simplistic, mundane research compared to some of the research that was presented here. But I can only do simple, mundane research. Okay. Again, nothing to do with my co-authors. Now, what is the entity heterogeneity problem? Here, did something for Hildam. Why are you giving me these things, Jack? I saw Ian also collecting things like that. What is the entity heterogeneity problem? Here, the identifier is not the same. We have different identifiers in different databases. And it's actually a major problem. Okay? So I'll mention why we started this work. And so you might think that, okay, identifier is not the same, but we can look at the other attributes, their values, and you would know whether these two records are the same. That means these two entities, instances are the same in these two entities. They're the same entity, but from the instances we would know these two basically represent the same instance. Okay? So when we started this work, okay, we thought about Unabomber. Some of you are probably too young to remember that. Okay? So Unabomber, there was a person named Tess Kaczynski. Okay? He was a very bright guy. He got into Harvard at the age of 16, got his PhD from Michigan, and then joined the Berkeley Math Department at the age of 25. He was the youngest faculty member at Berkeley at that point. Then something got changed. He left academia, became a recluse, went to Montana, stayed in the forest, and once in a while would send a handmade bomb to somebody. Okay? Typically in academia. He killed 3 people, injured a lot of other people. Okay? Now, frankly, many of us once in a while feel like killing somebody. But fortunately, we don't act on that desire, but he did. Okay, so we started the work, and that was an ideal situation of heterogeneous database, entity heterogeneity problem, because nobody knew who he was at that point, because it was being sent anonymously. Okay, and there were a number of federal organizations trying to identify who this person is. Of course, since they didn't know the personality, they didn't have the social security number. So they couldn't match. So we started working on that problem. While we were revising the paper, he got apprehended which shows sometimes good social deeds also have bad influence on your research. So this happened. But you might say, then why it is important? Why is he talking about this right now? By the way, I forgot to mention one thing. Some of you know that I'm having a fairly bad leg problem, so I'm on heavy pain medication now. So I might be incoherent at times. And some of you who know me well said, what's new? You are incoherent anyway. But I could be more incoherent than usual. Okay. Now coming back. So you might say, why is it a big problem now? So this guy got caught. Okay. But these days, because of security reasons, social security number is not used as an identifier typically. There are other IDs. Even those IDs are typically not disclosed from one place to another. So the problem still exists. So we have different identifiers, lack of a common candidate or primary key. Those who are not in IS, that candidate key has the same properties as a primary key. That means the identifier. And the general approach is that look at the other values. Look at the other attributes. There could be some common attributes. Not all attributes are the same, probably in the two databases for the same entity type. Then there could be differently coded data. There could be data entry error. There could be outdated data, and so on. And some common attributes may not be that predictive anyway. For example, if it's an employee, if an attribute is department, then it doesn't say much, because there are lots of people in the same department. If it's a professor entity, okay, faculty member, then rank doesn't say much. So they may not be very predictive. So is the idea more or less clear? Let's get into some math now. So two autonomous databases assume to be relational. You don't have to worry about relational or not if you are not in IS. Okay. So I have two relations, R1 and R2. They are exhibiting the same entity, real world entity type, do not have a common primary or candidate keys, and these are the common attributes. Not all of the attributes will have to be the same, because in one application there could be some other attributes compared to the other. So these are the two databases. One has m instances, one has n instances. And suppose these are the values of a particular attribute yk, okay, in the two databases. And Pij is the probability that in reality this instance is the same as the other instance given the values of the observed values. Given the observed values. Is it clear? Maybe I should have used my clicker, not yours. Okay, this is fine. I'm slow in terms of learning. So, okay. So suppose this is reality. I'm gradually thinking maybe I should use mine. Okay, this is reality. This is decision. Okay. And suppose AI equal to Bj. Thank you. So if in reality it is Ay equal to Bj and the decision is also the same, no error. Okay. Otherwise, this will work now. Thank you. Otherwise, there will be type 1 error. Where is my?
It's there.
It is there? You can see it?
Yeah.
How come I cannot see it? You can see, all of you can see the pointer?
Yeah. It's there.
Okay. The medication has other effects also that I didn't know. Anyway, as long as you can see, it's fine. So Pij is the probability that reality they are the same. So this is the probability at the bottom, and 1 minus Pij is the other probability. And there could be a type 1 error, a type 2 error, and so on. And this is the estimated cost, okay, on the two. I have to rush a little bit. Hope that's okay. I have to rush even more. Okay. So match if the cost of matching is less. So cost of matching, we found out this is the decision, is that, and this is the cost of not matching. So if the cost of matching is less than or equal to cost of not matching, so Pij is greater than alpha in this one. So this is the relative cost of type 2 error. So I can Xij is if you decide to match A1 with Bj and 0 otherwise, and the cost associated with this, and we have to sum over all. Okay. So databases are, within a database, the instances are unique. So we have these two constraints. We have another constraint in terms of the threshold, okay, and the decision variables and binary integers. So objective function is this, but actually we can take out this. So this becomes that, and that becomes a maximum function, objective function now. And interestingly, the other constraint that I mentioned before, this constraint is automatically satisfied there. Now I could even see it. So this is the model. But problem is estimating Pij would be very difficult if we don't have a whole lot of data. So what we could do, we could think about a distance measure, okay, where if Ai equal to Bj in reality, Dij is 0. If they are not, Dij is 1, but that's in reality. But we have to estimate based on what we see. So we can have probability of Dij is equal to 0 will be 1 minus Pj. So expected value of Dij would be 1 minus Pj also. So we can have a distance-based decision model, and this would be the model. And now it's delta, which is the relative cost of type 1 error. Fortunately, this is the weighted matching on a bipartite graph, an equivalent to an assignment problem, so there's a polynomial solution. And coming back, so there's a common solution algorithm, Hungarian algorithm, and there could be other algorithms also. Mohit, you probably would know there are better algorithms these days. So, so n is the maximum of m and n. Okay. So the question is, we have a model which we can solve very easily. So the problem becomes estimating the different parameters. So one is the distance parameter, which attribute level distance. Okay, we have to sum it up to the entity level distance, and also the predictive power. So it's Wk and Dijk. So Dijk is the distance between the values of attribute k for entities A1 and Bj, where k is one of the common attributes. And Wk represents the weight predictive power of attribute k elicited from users. Okay. Now attribute weight, actually, sometimes users may have difficulty telling you how predictive this attribute is, but they are much better in having rankings between attributes at different entities. So they can say, okay, this rank is higher, this rank is less higher, and so on. So we looked at the literature, and it shows that rank would be better, and you can get the weights from the rank, and there are different rank measures, and this is rank centroid. Okay, and if there are matches, ties, then it won't be the same, it would be different. So attribute level distance, there are many ways of looking at it. There could be numeric data, there could be binary logical data, there could be character string, and this is somewhat subjective. Okay? But there are common ways of doing it which you can follow. Okay? So what we did, there was MIS faculty directory. Now you can get online. So previously it was not online. So we looked at 1996 version and 1992 version, okay, and we didn't correct the data. If there are some errors we observed, we didn't correct because that would be real life. So there were 7 common attributes in total. So some name, affiliation, degree, research, and so on. 10 character, 5 logical, 2 integer. Okay. And what we did, we have number of records for 1992 and 96, and we actually took some states, okay, and gradually increased the states. So gradually the sets should be larger. So for example, like number 3, it will be 222 in 92, 226, 62, 96 again, and we can actually, since we know those faculty members, we can have the actual matches. So the actual matches in that case would be 155. That we know. Okay. So we are just testing how the algorithms would work. So here you probably cannot see anything. Okay. So we actually asked a number of faculty members who would be familiar to this database, that what would be the weights for different attributes, and the weight could actually change depending on whether it's a match or a mismatch. So we made them think about both sides. For example, if the email address matches, the 2 email address would match, then it's likely it's the same person. The probable weight is very high. Okay. On the other hand, they don't match, it may not be that weighty because somebody may have moved in these 4 years. Similarly, if it's the first name, okay, if it matches, it doesn't say much. On the other hand, if it doesn't match, it says a lot. So that's why we ask them, think about both sides and then give us the rank. Okay. So what we do, after we got all the people, okay, then we have a consolidated rank. That means we looked at the total ranks for all people, and the minimum would be number 1 and so on. Okay. So if you look at the data, you will see that between, say, when both types of errors are very similar, between say 0.4 and 0.6, we have very few errors. Okay. And when, of course, type 1 error is high, then we will have gradually more errors and so on this side, but less here, and just the opposite. So if you look at this, okay, you will realize that in the middle, if the 2 types of error are very similar, the number of errors, total errors, will be quite limited. Okay. And if you then we have to say whether it scales well with larger and larger databases. So we divided by, first of all, if it, look, again think about data sets 3, 228 and 262. Okay. So the maximum number of type 2 errors could be 262. So we scaled with that, and you realize with the scaling that actually it doesn't go up that much. Okay. Type 1 we could have changed. We could have said type 1s cannot be more than 155, so we could have used that, but we used 228 both to have equal type of thing. That we also get by this measure, which is relative information score. If you see that information score is practically 100%, okay, in that range. So at least in that range, it is very good. Now somebody might say, okay, here you have very predictive attributes like name. Okay. I don't want to show all those things, but without names also the results are pretty good. Then we actually thought maybe it doesn't matter. The results are actually insensitive. They will show good results all the time. So then we did reverse consolidated, equal weights, random weights. Then the results are much worse. Okay. So I did a good job. I finished the first one pretty quickly. Then I can relax a little bit for the second one. The next one is empirical. Here, both the authors are here, Muhammad and Jeffrey. Okay. And if there are any questions, they can answer. Okay. So let's talk about it. Again, I will try to rush a little bit, otherwise I won't be able to finish. Now, before I even go there, these days, the users are hyper-connected. They actually go to a store with their cell phone, other wearable technologies, and so on. So the retailers can actually pinpoint their position also. They know them, their position also. They can send discounts when they're entering a store. They can even sell discounts when they're looking at certain things near a shelf. And those things, they would send discounts for products on that shelf. Okay. Or, for example, they know somebody returns things quite often, certain kinds of products. What they might do, that as soon as that person enters the store, they would send a salesperson, associate, to steer her or him away from those type of products because they know their return pattern. Of course, there are huge privacy issues there, but there's a very well-known privacy expert sitting back there, Alessandro Acquisti, and it's very nice. He's coming here because he's coming this next Friday for a keynote speech at Purdue for their 150 year celebration also. So I won't say anything about privacy in front of him. Even otherwise, I won't say anything about it. But now I have an excuse. Okay. So there are two types of technology. So what is happening? The retailers can gain a lot of idea about somebody's sales and return patterns. The two types of technology that are commonly used on a website, one is a navigation technology, one is a product-oriented technology. Navigation technology means how you get to a product page. Okay? You can search. It could be a direct search. It could be a non-directed search. That means suppose you know what specific type of jeans you would like. Then you can just go to the product page. You may have the UPC number also. If you don't know in advance what specific things you would know, but you know you would buy a pair of jeans, then it's non-directed search and so on. Okay? Or there could be recommendations. And we use that on a paper for sales. I'm not going to discuss that. We don't have the time. The other type of technology is product-oriented technology. Once you land on a product page, there may be technologies for you to know more about the product. So there are three common technologies. One is zoom, okay, and one is alternative photo, one is color swatch. Then let's look at basically their idea, and I will go into them a little bit more detail later. These technologies are aimed at mitigating the lack of touch and feel in e-commerce type purchase. So helps better product evaluation before purchase, thereby easing uncertainties and fears. Okay. So let's look at these technologies. So that's zoom. Zoom means, okay, you focus on the product, see more things. Suppose the data we have, it's for women's clothing. You will see the stitches, you will see the buttons, you will see the ties, and so on. Okay. The other one is alternative photo. Here you will look at the product from different angles. But somebody is wearing the product in a scenic environment. So that could matter also. And then this is color swatch. You will see the colors, okay, in small blocks initially, but then you can see it on a model also. Actually, if I can digress a little bit, I was making a presentation and somebody raised his hand right at the beginning. I said, do you have a question right now? He said, yes. Right at the end of your career, finally you are getting into some exciting research. When I was okay, let's go to product returns. This is returns could be.
And they were saying compared to machine scheduling? Come on.
Okay, that's not a question. So this is allowed. Okay. Return rates could be more than 25%. And actually, if you look at all the returns, it's now, when we started writing the paper, we had some information. It's about $100 billion. Now it's about $200 billion. Okay. I should say that referees often say very strange things. One referee said, this is an insignificant problem. If $250 billion is insignificant, I don't know what is significant. Okay. And this is relatively most costly for retailers, internet retailers. And that's why they give more generous return policies, free shipping, and so on. Now, there are two senior marketing professors here. Okay. I hope they will be nice to me because there's some marketing issues here. Bala is there and Dipankar. They're well-known senior marketing professors, but also I think they're nice people, so don't say anything. Okay. Returning a purchased product is typically an outcome of a customer's dissatisfaction with the product. Okay. Hence, product returns typically stem from the degree of disparity or gap between pre-purchase expectation and post-purchase perceived product quality. So, pre-purchase expectation plays a significant role in determining product returns. I'm skipping some slides because I don't want to get into all those behavioral things here. We don't have the time also. Okay. But somebody might have to return. Suppose I bought something expensive, I lost my job, then I'm returning it. Those are rare situations. Typically, you buy something, then you get it, you don't like it as much as you thought you would like it, and then you return it. Now, two types of product information: factual information, which is more objective, okay, and tangible products, similar to the idea of fact is advertising, or it could be impression-based or evaluative information. It could be more subjective, emotional, and so on, similar to feelings. Factual information has the following effects: forms more realistic pre-purchase expectation, decreases the gap between pre-purchase expectation and post-purchase perceived quality. So, factual information has a negative effect on product returns. Okay. Impression-based information is just the opposite. Okay. May lead to unrealistically high expectations, and also there is some literature where it shows that your impression is guided by the best product image that you have, okay, and increases the gap. And there are also contrast and assimilation and so on, other things that we discuss in the paper. I don't want to get into that. So, impression-based information has a positive effect on product returns. So, let us look at the research context. It is a large internet retailer. Actually, that retailer had just one physical store in Florida, but we included and excluded the same results. They use all three product-oriented technologies: zoom, alternative photos, and color swatch, and they had about a little more than 1,800 products. So, we had two independent raters, both females. They knew and they are used to internet purchases, and they were actually PhD students. So, they were captive, so they had to do it what we asked them to do. So, and we saw that this statistical agreement between raters based on kappa statistics. So, basic findings are, again I am skipping some slides, that zoom predominantly factual information, okay, and that you would expect. Alternative photo predominantly impression based information, and color swatch impression based information is slightly predominant, and they are statistically significant, and again I won't go into all those things. So, I can give you some explanation why. Zoom, as I said, gives you more facts, okay. So, it is likely to be factual. Alternative photos, there are two aspects. One is rotation, that you see by rotating things. One is contextualization, and in our context you see somebody wearing a dress in a scenic environment. So, maybe contextualization is more predominant here, and that is why that was the result. And color swatch, actually when you view something on a larger scale, you might see more things. So, that is factual. And viewing it, somebody who is wearing the product, okay, it could be more impression based, but there is not a whole lot that you gain, because you see the pictures anyway in the small blocks, and when you click it you see more a little bit. So, it could be based on the result, it could be slightly predominant, impression based could be slightly predominant. So, what is the study design? All transactions made by every customer who made at least one purchase because you cannot return unless you purchase. But later on, we also have non-purchase situation. So purchase products includes information regarding if the product was returned or not, server logs, okay, and we know who got the catalogs. The company also sells catalogs. Who got the catalogs, when each catalog was mailed, what items were included in each catalog. We knew all of those. Okay. Transaction data was April 1 through April 30, 2006, and number of observations were 34,419. Non-unique products purchased by 10,205 unique customers. And let me mention what we mean. If somebody purchases 2 units of the same product, we counted it as 1, because the effect of technology would be the same. But if the same product is purchased by 2 different consumers, then we treat it as 2, because the 2 may be influenced by technology differently. And then we considered both purchase and non-purchase things also, and then it's a lot more. That's a subsequent analysis. So technology effect, if you use technology some time ago, then also it may have an effect. So we looked at the technology effect from a month before, and there were 52 million lines of logs, about 850,000 client requests per day. So it's a huge data. And when there's a good PhD student, devoted PhD student with a good computer science background, then these things get down. And Muhammad was still a PhD student at that time. Okay. Now probably he won't do it if we ask him to do it. So, and these are the controls. We consider only those subjects who got all the catalogs. Okay. Between February 1 and 2006 and April, because we gave it a little leeway so that the effect of catalog is taken care of. And the percentage discount, high discount meant lower likelihood of return, list price, typically return propensity would be higher if it is more expensive. If you buy something very cheap, okay, even if you don't like it, you may not like to return it. And time views, okay, how many times they viewed on that particular product page may represent a consumer's hesitation also. So this is the descriptive one. Here also you see the returns is more than 26%. Okay. And these figures for alternative photo, zoom, and color swatch is total number of usage divided by all the customers. And then we have, and the list price average is about $35. Okay. So it's a panel data model, okay, and this is our model where this is for zoom, this is for alternative photo, this is for color swatch, and then this is discount, this is, what are the other 2 things I forget now, list price and then times viewed. And this is the unobserved customer mu, unobserved customer heterogeneity, and the error time term. And we use random effects logic because we didn't use fixed effort there. The reason is typically when mu I is not correlated, okay, with the independent variables, that's the better approach. And our correlations were very low. And we also did later on fixed effects, and the results were very similar. So these are the results we got. Zoom usage, sir, you see that it does reduce return. Alternative photo, on the other hand, increases return. Okay? And color swatch didn't have a significant result. And the other one, discount, actually decreases, list price increases, which we expected, and times view also increases. So economic odds ratio, if you look at it, zoom usage actually reduces the odd of return by about 7%. Alternative photo actually increases by about 5%. Now, we also consider the impact of sales. Now, why should we consider the impact of sales? First of all, if there are lots of returns, but I also sell a lot more, the retailer may not worry about it, because sales minus return will still be positive. Also, those who are picky in terms of econometric analysis, they might say, okay, that we do not account for the impact of use of product-oriented technologies on non-purchase products, creating a sample selection bias. So, we use now a two-stage probit model, and we didn't know of any sample selection model, okay, for panel data. So, we had to do certain things. That means Muhammad had to do certain things. Okay. The first stage would be impact of sales, second stage would be impact of returns. So, two-stage model, if you look at Zoom, okay, you see that it's still reducing return. The first stage is sale, actually purchase, and this is return. The second stage, you still see the alternative photo is increasing, color swatch is not significant again. Now, somebody might say, how come sales is also reducing? Okay, Zoom usage. Actually, it's not significant, so we cannot say anything about it. Sometimes in business articles, the direction, we said the direction is that way, but I'm not sure whether we should say anything about it, because it's not significant. Okay, and in this case, that argument helps me, because I cannot really explain why it is reducing sales also. So, now we look at the marginal effects. Okay. Zoom usage, we see that it is indeed the marginal effect of sales minus returns, it's indeed reducing, and alternative photo is increasing. So, the problem, so we see that even when we consider, okay, not just returns, sales and returns, okay, then also actually alternative photo is not good. Okay. So, the key results are varying impacts on product return. Okay. Not every technology reduces return. Okay. Zoom would reduce return, alternative photo will increase return. Okay. Now, that is somewhat surprising, okay, that why would a retailer keep a technology which actually increases return, not only increases return, the net sales also reduces. Okay. So, these days we see a number of companies which let you actually post your own pictures. Previously, what happened? Always there, suppose women's clothing. Okay, the pictures will be about beautiful models wearing that product. So, the consumer might think that she might also think, look that way, once buy it. Typically, that doesn't happen, and they get frustrated and send it back. Okay. So, nowadays, many companies are doing it. Okay, so I'm sure not because of our paper. Nobody reads papers in Management Science and IS. Not nobody. We have to. We are forced. But most people in industry doesn't. So, they also figured that out. Okay. So, we see that the different technologies will have different effects. In particular, alternative photos require special attention. 1 unit of increase in alternative photo usage can increase the odds of for return by 5%. Alternative photo usage is detrimental to retailers even when we consider net sales. Firms should show pictures that help consumers from realistic pre-purchase expectation, and as I mentioned this. Now, let me mention one. Actually, I did a good job in terms of just rushing through everything. So, now I can say a little bit more. So, is alternative photo always bad? In the category of clothing, it could be bad. But now think about another product, a laptop, whether alternative photo would be good or bad. It would be probably bad if we still have more predominantly impression based information. Okay. But in a laptop, if you look at all sides, then you will know the different slots, how to connect different devices, how to connect to the power cord, and so on. So that could be more factual information. So in that case, that could actually help. So we are not saying that never use alternative photo. We are saying to the retailer that look at the different types of information that a consumer might gain from different technologies. Okay? That is the message we are sending, not that alternative photo is bad. Alternative photo could be bad in a particular product type, maybe good for other product types. Another thing I should mention that we did a lot of robustness checks, and I didn't think that I will have any time to go through them, but I didn't also know that I could finish everything early. So if you have questions, you can ask, and my co-authors are here. Is Jeffrey here also? Okay, so they can answer. Okay, Vida.
Vida, can I ask you to use this mic for the recording purposes? Just a moment.
I don't know why only mine is being recorded. It's almost like being captive here.
Thank you for a very interesting talk. So here's my question. The very first slide, you had 3 topics on it that you were able to
Yes.
abstract your work into these 3 general areas. If you were to add a 4th, what would it be and why?
That I have already done or I want to do?
No, this goes in the category of wisdom that you can pass on to us, that you would have liked to have studied,
Okay.
or that you think
That I would like to study?
or you think important.
Okay. It's difficult to say. First of all, fortunately, I'm retiring. I don't have to study. But you are talking about other people. I don't know. There's a lot of work that could be done on social networks. Remember, I mentioned that these 2 categories, okay, could be more general. That means it could go beyond IS in terms of topics. And some of the things that I did with Jeffrey and Hylium on social network, one is music sales, one is stock returns and income surprises and so on. Those would fall in that category also, but they already talked about it. Okay. So social network would be a big thing, and anything now related to all this, actually it's almost becoming a concierge system. That means a retailer can actually try to sell things as if it is acting as a concierge. That means it is just serving your needs, not everybody's needs, which are all good things. But the bad thing is that they know a lot more than what we think they know. That's why they can serve you also much better. So there's a huge privacy aspect also. So if somebody is interested in privacy, like Alessandro, then that would be a very fertile ground. And would you like to add to that? You are the man. Privacy.
Yeah, but from what specific angle?
Okay.
Oh, sorry. Add on the privacy as it relates to social networks.
Yeah. So, or anything in terms of e-commerce. Okay.
To me, the most interesting question were perhaps your interest and the interest of many people in the IS community and my own interest as someone who studies privacy relate to the allocation of value from the collection and the usage of personal data. There are many claims being made by the data industry about the value of collecting very minute consumer data and tracking everyone everywhere all the time is then distributed back to all the different stakeholders, merchants, publishers, consumers, data industry. I find that few of those claims have been vetted empirically and even theoretically.
Okay.
And I believe that this is an area where our collective wisdom, IS, marketing, privacy, econ, could really help. Because understanding really who is getting what,
Yes.
the value allocation, is a crucially important question considering how relevant personal data has become nowadays.
Sure. Thank you. So, Vida, collectively, did you answer your question? Okay.
Hi, Prabuddha. I have a question for you. Since you have been asking all these hard questions to us all this time, I thought I'll ask you some hard questions too.
Fortunately, I'm
yes.
at the end of my career, but go ahead.
Well, you still have a few minutes to tell us,
Okay,
respond to
fine.
this. So I'm going to be very critical about your research.
You are
learning.
always critical of me. That's not a new thing. Go ahead.
Machine learning,
Yeah.
operations management, databases, computer science, all this e-commerce, marketing. So why are you an IS faculty member? How are you an IS faculty member?
Okay, let me tell you one thing that at least I won't be here very long, but you'll continue. So you should answer that question. But Krishnan was saying something last evening. Krishnan was saying that, okay, in the business school, we're still doing econometric studies and so on. Those are important things, okay? But when he goes out and goes to organizations, talk to the CEOs, they see the value of optimization. Remember, optimization was very important. When we graduated, it was a main tool that we had to learn, and at least in a number of schools. And then the perceived value went down, in the business schools at least. Even now, in the business schools, it has not picked up that much, except for a few business schools. But when he goes talk to the CEOs and so on, they think it's very important. That's what you mentioned. So things are changing, okay? With machine learning and so on, they are basically helping that probably. So it's not just machine learning in isolation, econometric analysis in isolation. A combination of optimization and those things probably would be much better. But you can add to that.
I think Sumit is asking the question, why are you an MIS faculty?
Okay.
I think you belong to the world is the answer.
The good answer could be, first of all, he said, I belong to the world. And MIS covers everything. The second, I could say that, oh, I made a mistake, but you still have to go. So you need to decide.
We have all made this mistake.
Yeah, actually, remember at one point in the MBA program, teaching the core IS course was very difficult because we had to convince students that IS is important, okay? We had to convince students basically our existence. I think most students now realize it, that without IS, things won't be done properly, okay? So those days are gone, just like the days when we had lots of students coming for e-commerce and so on. Then there was a big problem, enrollment went down, but it's picking up again. But it's IS and analytics together. I think those two things, techniques and technologies, together, I think would be very important as a business education. I didn't answer your question, but at this stage, I know how to avoid questions, okay?
Anyone else?
Any other question?
Yeah, Bala. Oh, sorry. I'll go there.
Where is Bala?
Very interesting learning about heterogeneous databases. You know, I was thinking of how they match our offline shopping and, you know,
Online and
our
offline
browsing and all that. I mean, they probably don't have any primary key or something like that. So have you thought about those as applications of what you did, you know, in your work?
Not
there?
specifically.
Uh-huh.
In fact, some people, Sumit, remember, we also talked about that, why don't we try to patent what we did? So we didn't. Just like Jeffrey didn't make a whole lot of money by doing what he was doing. Academics are not very sharp in terms of making money. So maybe we should have done that, but we didn't. But it's a good problem. The problems are there. I wanted to discuss that problem, saying that although the Unabomber was caught during our revision, the problem still exists, and people should look at it.
So
You want to-
Prabuddha, mine is more of, in the nature of supporting you. Why are you an MIS faculty member? So you were on my committee at Ohio State. So you started the accounting and MIS program there. Then you
The
went to
MIS program, it was accounting department, and then
accounting,
it becomes
yeah,
accounting. and
Accounting,
MIS.
forget it, right? But in terms of, you started that MIS program, okay? And then you hired Hassan and all these other interesting people. All big mistakes, but you hired them, right? So, but in terms
I'm willing to make such mistakes
over and
again
over
and
again,
again.
over and over again.
Okay.
Then you went to Dayton and you started the program there.
And it
you
was
sa-
the first hire.
And then you came to Purdue,
Yeah.
and then you sort of revived this program from the days of Andy, and then you
Yes.
came and revived it and so on. So you have very legitimate reasons to call yourself an MIS person. So why are you so apologetic?
I'm not apologetic, but you were very nice. I didn't want to sound arrogant, but since you were saying that, it doesn't sound arrogant. We have 3, 4, 5 minutes. I'm very sorry that
Cold call. You can cold call. You like cold call.
No, even in class, I don't do it that much. Students hate me, even otherwise, let's not worry about it. Varghese, actually, that's a good point. I didn't even care. Sudha just got here driving a long distance. You want to ask a question? Sudha, you want to ask a
Ramesh
question?
is my former student. I defer to him.
How long did it take?
I have a very
to come
simple
in?
question.
What's-
In part of his talk, you talked about how industry does not read our papers and so on. Do you have any thoughts on how either we should do things differently to help them read it, or how you would have done things differently to help make that connection stronger? And
Industry would read certain things, like SMR, which is called MIT SMR these days. They would read that for sure. And because of an article in a special section called digital, is it digital frontiers probably, MIT, they wanted to do a webinar also, which we did this year. Okay, so industry people would, particularly senior industry people would read Harvard Business Review, SMR, and so on. You cannot really blame them if they are not reading management science and so on. In fact, we don't even read management science and so on if it's not directly related to our research. And they are not doing research, so nothing is directly related to them. So let's not worry about it. Are you in charge, and are you of also the professional MBA program?
I'm in charge of the
Online program.
So one last question, we have a minute.
Param creates problems, but anyway. Thank you, Mohit, for not asking a question. Thank you, Krishnan, for not asking any question.
I responded, I supported.
No, you supported, but didn't ask a question, which is good. Okay, Param, go ahead.
So Prabuddha, so what is your proudest and the most embarrassing moment ever in your career?
What does it have to do
Proudest
with a research
moment and
presentation?
an embarrassing moment.
What does it have to do with a research presentation?
Research could be embarrassing too, right?
He's asking an impossible question. He wants you to answer its proudest and most embarrassing.
At the same time?
No, different.
Okay, fine. Oh, okay. I don't know what is proud. I'm proud of many things. We hired good people, we had good PhD students and so on. Embarrassing things probably I should not get into in this forum.
All right, with that, thank you so much. We'll resume at 4:15.
Thank you.